There we go. So doing a significance test is a whole thing that's doing a 3-step process. Step 1, step 2, step 3. That's the entire significance test. That's what we're doing in 7.2. But again, 7.1, all we need to do is write the hypothesis. Sometimes in our hypothesis, we'll get a mean. We're going to compare the mean weight of tri-tips, right? And we're going to go barbecue some tri-tip this weekend. And what's the average weight? I'll take a sample of them and I'm going to compare them. Okay, the average cholesterol, how much cholesterol do people have? If the average cholesterol is 160, I forget how they measure milligrams per centimeter cubed. If that's the average, where are you at? If you got 180, compare those two numbers. Is 180 significantly greater than 160? Okay, so those are means. We could do proportions. So this could be a P. P stands for proportion. And I use the same 3 setups for my hypothesis. Is if I'm comparing proportions, like what percent of students wear glasses, right? What percent of students drive a lowrider? What percent of cars have black rims, right? You guys got the black rims on the car, all right? Or you got to paint them. So what percent of cars have black rims, right? So I'm going to take a sample, compare that to a population value, and decide, is there a difference? This means hypothesis HO means there's no difference. HA means there is a difference. Okay, so I could have proportions. I can also compare standard deviations or variance. If I compare standard deviation or variance, I'm going to do standard deviation. I'm just going to compare this. If I do variance, our hypothesis is going to be this. This is variance, standard deviation squared. One thing I don't like in 7.1, they introduce testing and then they talk about sampling errors. It's like, in hypothesis testing, you could make an error. So for example, in this problem, I rejected the null hypothesis. I said, I pretty much said, there's evidence that the average GPA is greater than 2.9. Okay, that's the winner. But I only asked 20 people. I asked 20 people, what's their GPA? And the average was 3.1. What if I asked like 50 people or 100 people? I'd probably get different results, right? So there's a possibility I could have made an error. I could have mistakenly rejected the null hypothesis. If I reject what I shouldn't have, that's called a type 1 error. Made a mistake. If I fail to reject, if I say, oh, the average GPA is 2.9, when I should have rejected because I had a small sample size, or my mean was just different than what the population is, that's called a type 2 error. Okay, so rejecting or failing to reject, those are type 1 and type 2 errors. So you'll encounter this when you go through 7.1. Type 1 error, they use Roman numerals. That's when you reject HO, when you should have rejected. Type 2 error is when you fail to reject. So if I fail to reject HO, I have the possibility of making a type 2 error. It's not a guarantee. Different way to think about it. Okay. If you're in law enforcement, right? I think somebody committed a crime, I arrest them, I throw them in jail. Like, you're in jail, you committed a crime. I have evidence that you committed the crime. I rejected when I probably shouldn't have. That's like making a type 1 error. They were innocent, even though I convicted them of crime. Okay, so there's a lot of people in jail that are innocent. They did not do the crime, they're in jail. Because I think they did type 1 error. Okay, sometimes that happens. Sometimes we mistakenly arrest people or we go to trial, we say, oh, there's guilty, there's not enough evidence of innocence. The opposite is true. Sometimes we find people innocent because there's not enough evidence that they committed a crime, although they did do it. Okay, you graffitied Hancock College, right? I found I think you did it, right? And I go to trial. I guess our security camera, you have a good lawyer or whatever. You didn't do it. You're free. Okay, you're innocent. That's the O.J. Simpson thing. O.J. Simpson is free, right? I don't know. It might be too long ago for some of you guys. O.J. Simpson, 1995, been a few years. But supposedly goes ex-wife and boyfriend, but found him innocent. He did not commit the crime. Well, he's not in jail. Everyone thinks he did it, but the court did not think that he did. So that's like making a type 1 and type 2 error. Type 1 error means there's evidence. Okay. There is evidence. Like in this problem, we had evidence to reject. There is evidence. And I'll talk about that word, if there's evidence or not enough evidence in 7.2. So if there's evidence to reject, we would reject the null hypothesis. We would say type 1 error. If we fail to reject, there's not enough evidence. Even though somebody committed the crime, we don't have enough evidence to convict them. There's not enough evidence to reject, even though they really did the crime. Okay. Cool. I think that covers pretty much all the details. Again, it's page 349. It's the big page that you got to refer to. There's a little table on the bottom of page 351 that kind of talks about that. I talked about innocence and guilty. That's at the top of page 352. There's a little table there, like type 1 and type 2 error. They talk about innocence and guilt over there. Justice means you find someone innocent when they're not guilty. Justice is when you find someone guilty when they really are. Otherwise, you make an error. There's mistakes in the judicial system. I'll talk about rejection decisions. That's page 356. I'll talk a lot about that when we get into 7.2. Otherwise, I'm going to give you about 45 minutes to work on 7.1, just writing the hypothesis statement, HO and HA. Pretty much all you got to do. A good thing to stand by is to write it in words and symbols. Okay, so you'll be given a question, write the question again, kind of repeat, kind of parrot the question. I call it parroting. You're just repeating, regurgitating what you see, and then write it in words. This is the words, and then these are the symbols. Okay, words and symbols. That's what you gotta do in 7.1. Cool. Yeah. Question. What are the problem sets?
Which one?
Okay. Let me pull it up real quick. $359, 26, $350 even. All right, about 45 minutes. I go to about 7 o'clock working on whatever you need to work on. All right, so any questions, anything in there up through problem 50? So again, writing the hypothesis statement, and then they had this idea of rejecting. I mentioned rejection decisions earlier. So if we get rejected, that means we're going to choose one of these two. So we write the hypothesis based on the question. Question comes, we pick 1, 2, or 3 based on the question. That's it. Then from there, we move on to our calculations. We get a z-score and a p-value. Well, what's p-value? That's a left tail area or a right tail area or two tail area. Well, we can get that p-value from our calculator. I got this number, this 0.9625. That was the area left. So I had to find the area to the right was 0.0375. Why the area right? Because I chose greater than. That's called a right tail area. If you choose greater than, or less than, we're gonna find a left tail or a right tail area. If I choose the left tail area, I'm just gonna look up the p-value, the probability. If it's two tails, then I have to multiply my area times 2. Okay, so those are 2 big things that we're gonna do here when we find the z-score. So in the calculation portion of it, the calculations we can do all on the calculator. Now, if we're given population standard deviation, in this case, population standard deviation was 0.5, we could do what's called a z-test. We did z-intervals previously. So to get a calculation, we could do right now, we're going to do a z-test. So let's go ahead and find that on our calculator. So we're in the same spot that we've been before. Stat. Go over to test. And the very first thing you see is a z-test, number 1. Okay, it's number 1. It must be pretty important. And it is, because testing, there are 6 different types of tests that we're going to do. Z-test, most important test that we're going to do. First question, do you have data or do you have stats? Well, we don't have data. Data was like problem number 12 on the quiz or on the test that we took. We had horsepowers for different measurements. So we don't have data, we have stats. U0. Okay, that's population mean. That's this number here. So the given. What's the mean GPA for everyone in the school? Well, we think it's about 2.9. I'm going to put 2.9 there. Population standard deviation 0.5. Sample mean is 3.1. Include 3.1 in here. Sample size is 20. So I put 20 in there. Then there's a new question. It's all brand new. It says not equals, less than, greater than. Don't choose one of the 3. There's 3 testing options. There's a not equals, a less than, or greater than. Well, in this case, we want to know is 3.1 bigger than 2.9. So I'm going to choose greater than. Then calculate. You get z-score 1.78. 1.788 to be exact. P-value 0.0368. Pretty darn close to that. This was because that number is rounded a little bit. The mean is 3.1 and it's 20. So in the calculation portion of the hypothesis test, we're going to write it in words and symbols. This is the words. This is the symbols. We're going to do a z-score and a p-value, those 2 things. And then we need to get to the conclusion. So here in 7.2, the really important part is coming up with a conclusion. What could you conclude about the population? Okay. So I wrote here, there's 3 things you need to conclude. You need to get a p-value and compare it to the alpha significance level. Now this alpha thing, sometimes it's 0.05, sometimes it's 0.1, sometimes it's 0.01. Most of the time you're going to use 0.05. That's why I wrote 0.05 there. Just like a confidence interval, most of the time a confidence interval is 0.95. We're going to reject or fail to reject the null hypothesis. And then we're going to answer the question. Well, what's the question? We asked the question in words. So I didn't really do it on this problem, but I'm going to do the conclusion. I'm going to write the conclusion in words and symbols. So it's just going to be a statistical way. I didn't really go through with the conclusion earlier. The statistical method of answering the question. Is GPA greater than 2.9? That's a yes, no question, isn't it? So I'm going to write the conclusion. First of all, I'm going to reject or fail to reject. So I'm going to go to step 3, the conclusion. Conclusion. So I'm going to say reject HO or fail to reject HO. Well, the p-value was below 0.05. Therefore, I'm going to reject HO. So I can do it two different ways. I can write reject first, and then cite the p-value, or I can cite the p-value first, and then say reject. Okay. So I'm going to say reject HO. And you don't actually have to include the p-value in your conclusion, because I already know what the p-value is that you found, because that's in the calculation portion of the hypothesis test. So I did two things there. I said reject HO, or we could fail to reject HO. We do one of two things. We either reject or fail to reject. So I rejected HO. The p-value is less than 0.05. That's the second part. P-value is greater than 0.05. We fail to reject. Now I'm going to do what's called answering the question. Again, I'll go back here. I rejected this one. It's not this one. It's the other one. Since the p-value is less than 0.05, I'm going to reject HO and conclude GPA is greater than 2.9. Now, sometimes you'll see the word evidence or not enough evidence. So this is kind of a little extra. If you reject, we say there is evidence. There is evidence to reject. It's kind of an added bonus, like when you're writing your conclusion. To reject, you say there is evidence to reject. If we fail to reject, there is not enough evidence. All right, cool. So we have three kinds of tests we're going to make. We have 3 steps we're going to follow. We follow those 3 steps, we'll reach our conclusion. Now, the book does this. The book will say, write your hypothesis in words. Part A. Part B. Write the hypothesis in symbols. That would be part B. Part C. Find the z-score. Part D. Find the p-value. Part E. Rejection, decision. And then finally, answer in context of the question. So if you follow the guidelines, if you're following the book step by step, I know a lot of people like to do that. Like, here's the book, here's an example. I'm going to do exactly what the book tells me to do. Okay. If you follow the 3-step process, you'll get your conclusion. You'll get the answer to the question. The guidelines will change, though, as we go through 2-sample testing. We go to testing for proportions. We go to chi-squared testing. If we go to hypothesis testing for regression, our guidelines will change. But these 3 steps won't change. These 3 steps are not in the book. The book uses guidelines. And if you read the guidelines, they're on page 365. They give us like 8 things. Like, how are you going to memorize 8 things to do in a hypothesis test? Okay, go ahead and make some flashcards, make your guidelines 1 through 8. You're going to memorize those things. Okay, not really. I'm asking you to memorize a 3-step process. Well, you don't really have to, because on the quiz, here's the quiz. I'm going to give you a question. The question says, state the question. Part A. Part B, calculations. Part C, conclusion. 3-step process. Okay. So that's kind of the idea of it there. All right. Again, I don't normally follow the examples in the book, but there's a couple good examples here. There's 2 ways to make your rejection decision. We can make our rejection decision based on p-value, or we can make it based on rejection regions. half of this section talks about rejection regions, and the answers in the back of the book talk about rejection regions, and the book really avoids p-value. But when we do a test on a calculator, we get a p-value. So I'm going to rely on the calculator. I'm going to rely on the p-value to make my rejection decision. So it kind of deviates away from the book a little bit when they talk about hypothesis testing using rejection regions. We're going to avoid that. It's just complicates things. Plus, this is summer school, and we don't have enough time to go through all these rejection areas and left tail, right tail, two tail, and stuff like that. So I want to get an idea of all 3 different types of tests that we could do. So I want to do a left tail test and a two tail test. I want to read, we're going to read example 4 and 5. We're going to go through both of those. We're going to take our time. We're going to be like 10 minutes. Read through example 4. See how they get the, try to look at where each of these steps come into play in example 4. Then I'm going to talk about it. I'm going to go through it. I'm going to give you about 10 minutes to try to understand what the question is talking about, and then I'll go through it. We'll do it on the calculator and short some things up from there. Okay. All right, go for it. 10 minutes. All right, so again, example 4, page 366. Pit stop crew, they stop to change the tires of a car, gas up, all that stuff. The average pit stop time is 13 seconds. They do it in 12.9 seconds on average. Is that faster than 13? Does it take less time? So if you read the question, again, you're looking for the question mark. They claim the mean pit stop time is less than 13 seconds. There we go. We're going to do door number 1, door number 2, or door number 3. Less than. Where's less than at? Okay. Right there. See less than? And again, we can refer to that page 349 if you don't know. So then we're getting into words. We're going to do word problems. It's going to get into words. These are the most common words you're going to see. But if you're confused, go to page 349. It tells you which one you're going to use. We're going to use that. We're going to use this hypothesis. So in words, what we're going to test is 12.9 less than 13. It's 12.9 less than 13. So we do the z-test and we get a negative 2.98. I look up a z-score of negative 2.98 and I get a p-value of 0.0014. Conclusion. So right here, the p-value is below 0.05. Reject HO. So this is a little bit different. They use significance level and stuff like that. I think the significance level is 1%. This is 5%. They use 1%. But anyways, p-value is less than 0.01. We're going to reject HO and conclude that their pit stop time is less than 13 seconds. 12.9 is less than 13 seconds. Okay, we're going to do this on the calculator now. So let's see here. Why is this a z-test? This is a z-test because they give us the standard deviation. Population standard deviation was 0.19 seconds. And that's the very last thing in the sentence. It says, assume the population standard deviation is 0.19 seconds. So again, stat, go to test, go to z-test. mu0, 13. Standard deviation, 0.19. X bar, 12.9. N, sample size, 32 pit stops were measured. We're going to choose not equals, we're going to choose less than, or we're going to choose greater than. In this problem, we choose less than. Then we calculate. C is negative 2.977 or negative 2.98, exactly what they got. P-value, 0.001. Okay. There's your question in words and symbols. The symbols are this one right here. The z-score, -2.98, p-value 0.001. Conclusion, since p-value is less than 0.01, we can reject the null hypothesis and conclude there's evidence that pit stop times are less than 13 seconds. We rejected. There is evidence pit stop times are less than 13 seconds. Cool? All right, so this is called a left tail test because we measured less than is 12.9 less than 13. We do this with money, we can do this with weight loss, we could do this with any object where I got a mean, population mean, and sample mean. Compare the two. We're comparing two means. The average cost of college, right? If the average cost for Cal State University is $20,000 a year, and the average cost for a UC is $26,000 a year, let's compare the two. Is there a difference? Well, we need a sample. We need a sample measurement. I think USC this year is going to be $80,000 to go to University of Southern California. Okay, $80,000. We got to take a sample and make a comparison. Same thing if you're looking at a job. Anybody looking for a job? Like you're in this class because you want a job in a certain field, right? You don't want to just look at what you could make. Oh, I have a friend that was an insurance agent. He wanted to get his business degree in Cal Poly in insurance, selling insurance. Oh, you could make $150,000 a year. Well, guess what he started out at? Like 40. You could make this much, but what's the average? You got to ask some people. You got to take a sample. You got to get some sample data and make comparisons to population. And that's what this is all about. All right, so we're going to go to example 5. Example 5 is a two-tailed test. So in a two-tailed test, p-value is a little bit different. You get your z-score, you're going to multiply by 2 to get your p-value. So again, 10 minutes. We're going to take 10 minutes, read example 5, page 367, get an idea of how the z-score is calculated, get an idea where p-value comes from, and we're going to do it in the calculator. We're going to talk about it and see where all our calculations stand. Cool. All right, so we're comparing the actual costs that we found in a sample of people and a predicted cost, $21,500. We're either equals or not equals. How do I know? The surgery costs $21,500. There was no words like less than, more than, at least, at most, not more than. I didn't see any of that stuff. It either is or it is not. Is in math world means equal. Bariatric surgery is $21,500 or it is not $21,500. So we're comparing these two numbers, the 20,695 and the 21,500. Is there a difference? I get a z-score of -1.79. I'm going to go look up that z-score. Okay, this is where things get a little tricky. If I go look up -1.79 in my table, -1.79 is 0.0367. Well, that's not the p-value. E equals 0.0367. That's not p-value. The p-value is twice that because I have a left tail area and a right tail area. I didn't know if the mean cost was 21,500. I didn't know if I was going to be greater than that or less than that. So I got to multiply. It says 2 times. If you're looking in the example number 5, 2 times 0.0367 is 0.0734. Then we're on step 3. We're in our conclusion area. So we're going to do the 3-step process here. In our conclusion, we're going to reject or fail to reject. Well, I got to compare it to my alpha significance level, which is 0.05. Okay, p-value is greater than 0.05. P-value is greater than 0.05. I'm going to fail to reject. Fail to reject. HO. P-value is greater than 0.05. Not by much, though. There's some evidence that there's a difference, but $20,695. You're gonna spend $20,000 bucks. $20,695, $21,500. Not much of a difference between those two numbers. Okay, that's what this conclusion is telling us. The color reject P value is greater than 0.05. Does surgery cost $21,500? I guess so. Right. I think the average is, so I'm concluding this one. But statistically, if we conclude HO, that's the same as saying there's not enough evidence that there is a difference. And that's what we use. We use that language. Not enough evidence that there is a difference. Not enough evidence of HA. So there is not enough evidence there is a difference. Or you say there is, the bariatric surgery is $21,500. Enough evidence. Cost is different. I use the word different instead of the word not. The book uses the word not all the time. I use the word different. This means there's no difference. This means there is a difference. Not enough evidence, there is a difference. Or not enough evidence, the cost is different. There's many ways to write the conclusion. It's different than $21,500. Fit that in there at the bottom. Not enough evidence that there's a difference between $21,500 and $20,695. Really, there's no difference between those two values. One is close to 21,000, one's close to 21,500. Not much of a difference. Okay. That's like gas prices. $6.09 a gallon. Across the street, $6.15 a gallon. You're gonna go around the block and do a U-turn to go to the cheaper gas station. Probably cost you that much money just to go around and wait in line over at Costco to get gas. I see all these lines for cars waiting in line to get gas, and they're wasting all this gas to get gas, all this stuff to save 5 cents per 1 gallon. If you have a 20-gallon gas tank, that's $1. You just saved $1 by driving all the way across town to go get cheaper gas. Saved $1. Well, you didn't really save $1 because you had to drive across town to get gas and wait in line. Okay, so time is sometimes more important. Save $1, right? So it depends on what you want. Anyways, that's a left tail test, a two tail test. There is also a right tail test. That's like greater than. We didn't get to many of those. More than. We'll get to a lot of those. 7.2 is Z testing. We're going to do a Z test in 7.2. In 7.3, we're going to do a T test. In 7.2, we're going to do a Z test for proportions. So it kind of follows the same thing as chapter 6. We're doing a Z test or a Z interval. Then we do a T interval. Then we do a Z interval for proportions. We're going to do Z test, T test, and a Z test for proportions. Pretty cool. Yeah. All right, sounds good. That's it for today. That's all we got. All I got. Just got to work on homework and do your best, what you can. But like I said, you're adults. You're free to stay. You're free to go. You do whatever you need to do. And see you tomorrow.